Okay, folks, now we're going to think about how you can calculate the instantaneous speed of a projectile at any given instant. But again, it's really important to understand conceptually what's going on. So here's a little animation. Um, as as you watch it play, notice that the horizontal speed doesn't change. The vertical speed is going to decrease. It's going to be 0 for an instant at the peak, and then it's going to increase on the in a negative direction. So if we can we reset this? Look at notice that this is your instantaneous horizontal component. That's always 3.54. The Vy, since we're on the downside, is increasingly negative. And then the magnitude, that's what we're going to focus on right now. The magnitude we're going to see is the Pythagorean theorem of these two numbers. And then this is the instantaneous angle, this turquoise angle highlighted in turquoise. Let's see. Oh, yeah. So if we reset it, the other thing I want you to watch is, so it's launched with a speed of 5. It is less than 5 at all points above where you started. Again, you can think of this from conservation of energy. You could check your work now that if you know how to do that. I'm recording this after we've done that, but we may not have done this yet. Okay, and then again, at the peak, it only has its horizontal velocity. It will never lose that horizontal velocity. So I'm not quite, you can see the angle's 1.83. It's not 0, so I didn't quite pause it at the peak. But the Vy is so small to not be making a significant change it to the hundredths place. And then Vy is now negative. The total speed is 3.87. So you know you are still above where you started because 3.87 is less than 5. And then when it comes back to the height where it started, it's 5. So I stopped it a little too late. It's now 5.1, and that speed is just going to get bigger and bigger and bigger and bigger. Vx is staying the same. The reason the magnitude of the vector is getting bigger is because the Vy is increasing in length. Okay, so and then I think that's it. So important to understand what is happening to the speed. All right. So we did that. You can pause this and write any of this down. Absolutely write this down. So whenever it says calculate the speed of a projectile, up to now, when we did one-dimensional motion, speed was just use the velocity function, done. Now just think of it as a process, like calculating the total force on an object or something. So it's a 3-step process. Step 1 is making sure you have Vx somewhere and just recognizing, okay, I got to go find Vx. Hopefully I have it somewhere. Write that down. Step 2, actually calculating Vy using the velocity function. So only using the initial vertical velocity and then, 9.8 and the time that you're interested in. And then this is what's new. The speed is we're undoing what we did when we broke vectors down, right? So we took the force and we said how much is over and how much is up, but we rarely calculated the speed. So let's say the speed in the horizontal direction was 3 and in the vertical direction it was 1, and what I want is the actual total speed. So it's going to be the hypotenuse, or this amount squared plus that amount squared. One quick word of warning before we do an example problem. If it was 3 meters per second over and -1 meters per second down, don't make the algebraic mistake of saying the speed is the square root of 3 squared minus 1 squared and getting 9 minus 1, the square root of 8. It's 3 squared plus -1 squared. So it's the square root of 10. It's not the square root of 8. Okay, if you did that, then you'd get a hypotenuse less, that is shorter. If you made the mistake, you would get the hypotenuse was less than one of the legs, less than 3, which is impossible. Okay, so please, what? And you can just ignore, put the minus sign in parentheses or just ignore it because you're going to square it. All right, example problem, and then we're done with this video. So you have a soccer player kicking a football, or sorry, a soccer ball with a speed of 16 and an angle of 28 degrees. And somewhere down, well, not somewhere, sorry, specifically 16.8 meters away, there's the goalie. And the goalie is going to jump up and catch it. And we want to know the speed that the goalie is catching it. Sorry, it's not hitting the goalie in the head. We want to know what the speed is right there. Okay. So again, they're asking you about speed, but there's a lot of extra stuff you have to find in order to do that. So the first thing you're going to do is break this down. 16 cos 28, I know you'll know how to do that. So that's 14.13, and 16 sine 28 is 7.51. And then cross out the 16 so you don't actually accidentally use it. And we don't need the 28 either, but whatever. Okay, I think I chose this problem because many times projectile problems are over when it hits the ground. But that's not always the case. There's some problems where it's like there's a fire person with a fire hose and it hits the building and the building is so many meters away. We don't know where the projectile is vertically, but we do know where it is horizontally. Okay, so that's a hint that we're going to use the horizontal Sudoku to get the time, not the vertical. All right, so the soccer ball starts at 0, but ends at 16.8. The initial horizontal velocity is 14.13. The acceleration is 0. We don't know the time, but we care. And you're never going to use this box because this is always constant. Okay, so it's always the same. So what we know is this row is complete. So we're going to use our horizontal position function with no acceleration. To find the time that it is right, above the goalie, and you get 1.19 seconds. Okay, so we had to find Vx, we had to find Vy. We now know the time, and now we want the speed. So whenever you see the word speed, I would just write down 1, 2, 3. Step 1 is saying, oh, let me organize Vx. Step 2 is let me calculate Vy. And so 7.51 minus 9.8 times this time is negative 4.152. So that tells you that it's on the way down, which makes sense. And then step 3, and then we're done, is the speed is 14.13 squared plus negative 4.152 quantity squared, which is the square root of 217, which is 14.73 meters per second. Okay, I'm going to say a couple of hints and warnings or whatever, but we're almost done. I made a mistake when I did this out at first, and I copied this to be 1.9. So if you run the math, it's apparently after it hit the ground. Anyway, I got a Vy of minus 11. And when I found the speed, it was actually bigger than 16. So I knew that was wrong. So I went back and checked my work and actually found the YouTube of this solution that I made and realized where I'd made the mistake. So check your work. 14.7 is less than 16 because even though it's on the way down, it hasn't hit the ground yet, right? So you could use conservation of energy to find the height. You could use physics Sudoku to find the height. And then I thought there was one other warning I wanted to give y'all. Oh yeah, I just wanted to draw you a picture of what that speed is because we haven't done this a lot. So because occasionally they'll say find the angle. So it's headed over at 14 and down at 4.15, and what we found was this right here is 14.73. So you can see that the 14 is so much bigger than the 4 that it's, that this angle is more shallow than I drew it, and that this hypotenuse is pretty darn close to the length of the purple side of the triangle. But that's what we're doing. There's a lot of information here, right? This is how quickly the football is going across the field. This is instantaneously which way the football is headed vertically. But if it had a speedometer on it, this 14.73 is the actual speed of the football. Okay. And then again, if they asked you for the angle, you can do whatever inverse trig function you want to find the angle. Generally, you would say inverse tan of opposite over 14 over adjacent is the easiest to me. Okay, so moral of the story is speed isn't a tough concept, but you got to have it. We don't do it a lot. We normally do the sine and cosine. We find the legs from the hypotenuse, and now we're finding the hypotenuse from the legs. All right, so do enough of this practice so that it is second nature, and hope it goes well for you.